And then take everything from him. Let him feel like Jesus felt, that virtue has been taken out of him. Don't miss this opportunity. Tomorrow we are coming. Don't miss this opportunity. Please. So, Mr. Peter Ogu, these are a few of my science teachers. Let us Jojo to find out how we can help the teaching and learning of science. Because we are having a lot of difficulty. And I know with your coming, it will be the beginning of many good things to come. Thank you. Thank you so much.
Thank you very much.
So can you call your friends?
Then let's bring that one for so that you come and sit for
Yeah.
you come later.
Yeah.
So
I
maybe
want you
if you enjoy that,
hazard. So we have test of practical on all these topics. But I'm representing one of the separation. Figure 3b illustrates the separation of a mixture in the laboratory. Study the diagram carefully and answer question I, IV, and V.
Can I tell you a story?
Yes.
One day I was doing myself.
The separation is on filtration. So our setup is being held with the rator stand, by the help of rator stand. We have our beaker position beneath the funnel. So the rator stand has held the funnel in position. So here are the questions I have. Question I. Name the method of separation in figure 3b. Illustrated in figure 3b.
But that was not the illustration. I mean, that was not the figure.
Then II. Name each of the parts I to IV.
No. You see, when you ask it like that, name each of the parts.
Name each of the parts labeled IV, and V.
Good.
4 marks. III. State the class of mixture the experimental setup could be used for. 2 marks. IV.
State the time.
The class of mixture.
The class.
Yes, please.
Yes, I know you want sorry, liquid. But what we are asking for one information, you are giving 2 marks. Why?
Take the function of the part labeled II and III. 4 marks.
Of the parts labeled I,
And III.
5 marks.
Which other method of separation could be used for the same purpose as this method of separation?
What was your mission?
My mixture is muddy water.
Yes, but your question says the class of mission.
Yes, please.
The class of mission is no matter what. That you are the father of the child. Because this person will have a normal skin color. This also will have a normal skin color. Because A is dominant over small a. B is dominant over this. And this one is homozygous, so there are 2 big A's. So normal skin color. And that's why we say the phenotypic ratio in the F1, first generation, is 3:1. 3 normal to 1 recessive. Yes, that's what they was. And I told you yesterday that there are 2 areas of the syllabus that I'm in love with: the genetics and organic chemistry. Anyway, so that's about Mendel's law. That's about Mendel's law. The point I'm making is that we shall always be careful and answer the questions that follow. That's a beautiful question. The first question is, name the phenomenon illustrated. And the phenomenon is refraction of light. Not just refraction. Because sun can also get refracted. That's why many students will write a refraction and leave it there, and it's wrong. Refraction of light. Then the next question is, make each of the parts labeled I. I, and so on. Then, are you with me?
Yeah.
Isn't it? Then name each of the parts. So the first one was 1 mark. Name each of the parts. 1, 2, 3, 4, 5. 5 marks. I'm aiming at my 13 marks. Isn't it? Yes. Then I will decide to draw about 5 different diagrams of this, showing different angles of I and R. You have that in your mind? I can draw 5 more of this, and I'll ask the student measure each of the angles I and R, and provide the answers in the table provided. Have you seen questions like that before? So if they are measuring I for each of the 5 diagrams, that's why in the red case I'll give for measure angle using their protractor, they should know. So I will give half. I can't give 1. It's too much. But the 5 diagrams, I'll get 5 marks, isn't it? Okay, I'm nearly my text, isn't it? Yes. Then I'll go beyond you now, go to SSS. I'll ask them to draw a graph. First of all, in the table, I'll ask them to find